Another important concept that I want you to have a revision of is the concept of probability. So what is probability? Probability is quantifying the chance with which the stated or nominated outcome of an event will take place. In other words, we can say that probability is the measure of likelihood of an event. So by convention, when we calculate the value of probability, the value lies on a scale between 0, impossibility, and 1, certainty. And this is the simple example of coin tossing, that how we can calculate probability. Probability is number of nominated outcomes divided by the total number of possible outcomes. So the event here is coin tossing. Outcomes could be head or tail. So let's suppose our nominated outcome is tail, that we are calculating the probability that what is the probability that tail is going to appear in one event of coin tossing. And what are the total number of possible outcomes? These are head and tail, so there are 2 possible outcomes. So what is probability? Probability is 1 by 2 or 0.5. So the probability of tail in a single event of coin tossing is 0.5. And then we have another example. In a jar we have a collection of jelly beans of different colors. So there are total 36 jelly beans, out of which 10 are red, 9 are white, 3 are blue, and 14 are pink. Event is picking one jelly bean from the jar. Outcomes could be red, white, blue, or pink. So nominated outcome, for example, is red, that how many times red is present in this, and we are picking up one jelly bean from the jar. So what is the probability that one jelly bean is going to be the red color? So how many jelly beans are there of red color in the jar? There are total 10. And how many are total jelly beans? There are 36. So 10 divided by 36 is 0.2778. So probability of picking up a red jelly bean in a single event is 0.2778. And another example, we are taking the example of a pond which is inhabited by 2 species of meniscus midge, Dixella autumnalis and Dixella attica. And their pupae are morphologically similar, and they are randomly and independently dispersed in the pond. So long-term studies on the population composition have revealed that out of every 100 pupae collected, 80 will emerge as Dixella autumnalis and 20 will emerge as Dixella attica. And the male to female ratio is 1:1. So out of every 2 pupae collected, 1 will emerge as male and 1 will emerge as female. Now, event is hatching of one pupa collected from the pond, because their pupae are morphologically similar, so we cannot differentiate between the 2 species when they are in their pupal stage. So if we have picked up one pupa from the pond, so what is the probability that this pupa will emerge as Dixella attica or Dixella autumnalis? So outcomes could be Dixella autumnalis or Dixella attica. Nominated outcome, for example, is Dixella autumnalis. So what is the probability? 80 by 100, so 0.8 is the probability. So probability of a pupa to emerge as Dixella autumnalis is 0.8. And probability to emerge as Dixella attica is 0.2. The nominated outcome, for example, if it is male, then the total number of possible outcomes are 2. So probability of a pupa to emerge as male is 0.5. And probability of pupa to emerge as female is also 0.5. Now the other important thing is that sum of individual probabilities of all possible outcomes is equal to 1. In case of coin, there were 2 possible outcomes, head and tail. The probability for head was 0.5 and probability for tail was 0.5. So their sum is equal to 1. Similarly, in case of pupa species, the probability for Dixella autumnalis is 0.8 and for Dixella attica is 0.2, and their sum is equal to 1. Pupa sex, probability for male is 0.5 and probability for female is also 0.5, and their sum is equal to 1. Probability distribution. So what is probability distribution? It is the breakdown which shows the individual probabilities of all possible outcomes and which adds up to 1. So probability distribution of outcomes, and this is for the jelly beans. example. So we had 4 colors of jelly beans, and we calculated the individual probabilities of each one of these colors, and when they are presented in the form of a table, that is known as a probability distribution. Compound probabilities. So probabilities, they may be added or multiplied. So previously we saw the examples where we were calculating probability of a single event or probability of a single outcome. So the compound probabilities are also used in statistics, and this means that probabilities, they can be added or multiplied. That if you want to calculate the probability of 2 consecutive events or 3 consecutive events, or if you want to calculate the compound probability of more than one outcome, so that can also be done. So in that purpose, the probabilities, they may be added or multiplied. For example, in case of jelly beans, what is the probability that a jelly bean will be either red or blue? Probability of red is 0.2778, probability of blue is 0.0833. So what is their compound probability? It is 0.3611. Pupa sex and species, probability of male Dixella autumnalis is 0.5 for the male species, and for the male fly, and 0.8 for the species autumnalis. So their compound probability is 0.4. Probability for female Dixella autumnalis is 0.4. Probability for male Dixella attica is 0.1. Probability for female Dixella attica is also 0.1. And their total probability of all these possible outcomes is equal to 1. Then the critical probability, which is very important in statistical analysis. So critical probability is the probability below which the stated outcome of an event is unlikely to occur, and it is decided arbitrarily. And these are the levels of critical probability which are used in statistics. So the first level of critical probability is probability of 0.05. So if an event is having a probability, or if an outcome is having a probability of less than 0.05, it means that that event is unlikely to occur. And if that event occurs, that event is said to be, or that outcome is said to be, a significant outcome, because the probability was very critical, probability was unlikely. And the next level is 0.01, which means very unlikely. So probability of an event which is less than 0.01 is said to be a very unlikely probability, and if that outcome occurs, it means that that outcome is highly significant. And the highest level of critical probability is 0.001, which means that the event is highly unlikely, and if that outcome occurs, that is said to be a very highly significant outcome. And all the probabilities which are greater than 0.05, they are said to be likely, and if they occur, they are said to be non-significant.